In this video, I will show you how to multiply one matrix by another matrix, and I'll let you know when that's okay and when that is not possible. So first of all, the product of two matrices A and B is only defined if the number of columns in matrix A is equal to the number of rows in matrix B. And if matrix A is an M by N matrix, all right, these are the dimensions, the number of rows and the number of columns. So if matrix A is an M by N matrix and matrix B is an N by P matrix, then the product is going to be determined by the outer dimensions. Okay, here and here. So the product is going to be an M by P matrix. Okay, so in order for it to be defined, the inner dimensions must be the same. So when we talk about the number of columns of matrix A and the number of rows of matrix B, we're talking about these two. See how they're the same? All right, that has to happen. But then the product, the result, is going to have the dimensions of the outer dimensions M and P. When multiplying matrices, you multiply elements in a row from the first matrix by corresponding elements in a column of the second matrix. The sum of these products gives one element in the product matrix. Now, if you don't understand a word I just said, that is understandable. This is the type of thing that it's best to do an example and see what I'm talking about. It's hard to understand just from the words alone. So let's do an example. We're going to multiply matrix A times matrix B. First, we have to figure out if this is even going to be possible. Is this product defined? So consider the dimensions of matrix A. The dimensions here are 3 by 2 because we have 3 rows and 2 columns. So dimensions 3 by 2. Now, the dimensions of matrix B, of course, we have 2 by 2. All right, 2 rows and 2 columns. I'm going to take these dimensions and write them a little bit closer side by side. For the product of A times B to be defined, the inner dimensions have to be the same. Okay, these must be the same. And they are. So we can multiply A times B. Now, the dimensions of the product matrix AB will be the outer dimensions. So matrix AB will have the dimensions 3 by 2 because of the outer dimensions 3 and 2. Now that we know that AB has dimensions 3 by 2, let's set up an empty matrix that has those dimensions 3 by 2. Now for this first example, I'm going to set up a huge empty matrix with enough space so I can show you every step. Once we know what we're doing, you'll be able to make this smaller. So again, AB is a 3 by 2 matrix. That means I need 3 rows and 2 columns. So I will set up my empty matrix. I'm going to use lines to help me out. So I am going to use these lines to set up for 3 rows, and I need 2 columns. So I can just go like this. So this is my empty matrix where I'm going to show all of my work. All right, and again, I know this is huge, and this is just so I can show every step. But once we know what we're doing, I'll show you how to shrink this down. Now, here's the key to matrix multiplication. We are going to be multiplying rows by columns. So please understand that the rows are all going to come from the first matrix. So when you look at the first matrix, we're going to be dealing with rows like this. Boom, boom, boom. And we will be multiplying by the columns of the second matrix. So the second matrix is all about columns. Boom and boom. So just keep that in your head. We're going to be multiplying rows by columns. All of the rows will come from the first matrix, and all of the columns will come from the second matrix. Okay, let's start with the first entry, the first element. This is row 1 and column 1 of the answer. So we will find the element in row 1, column 1 by multiplying row 1 times column 1. So we're going to multiply row 1 from the first matrix times column 1 of the second matrix. So in order to do this neatly, I'm actually going to write my rows and columns both vertically. So I hope that doesn't throw you too much. So I'm going to take row 2, 1, but I'm going to actually write it vertically just to make my calculations easier to do. Right, but this is obviously row 1. And I'm going to multiply that by column 1. So this is 3, negative 1. Okay, so let's do that. If I multiply these together, this is going to be 2 times 3. So that's going to give me 6. And then 1 times negative 1 is negative 1. And then what I do is I take the sum of these. So that's going to give me, if I take these and add it up, I'm going to get 5. I decided to write it this way instead. So this 5 is the element of row 1, column 1 for my answer. So I'm going to go ahead and put that 5 right here. Okay. Now, let's say if I wanted to find the next element over. Now, this is row 1, column 2. So I'm still dealing with row 1, but now I'm in column 2. So I'm going to multiply row 1 by column 2 because I'm in row 1, column 2. So once again, I'm going to take row 1 from the first matrix, but now I'm going to have column 2 of the second matrix. And I will multiply and add. So this is going to give me negative 4 and 5. And then if I take the sum of these, that's 1. So this is my element of row 1, column 2. So that will go here in my final answer. And I'm just going to do this over and over again. Now, one way that you can make this process a little bit faster is by duplicating your rows and columns. So you notice I'm doing row 1 because I'm in row 1. And then, so notice when I got over here, it was still row 1. I'm still in row 1. Now, when I come down to row 2, I'm going to switch to row 2. All right, so now both of these are row 2. So I might as well write them down at once. So row 2 is negative 3, 4. So I'm going to write that down. But over here, I'm still in row 2, so I'm still going to be doing negative 3, 4. Okay, I might as well do them all at once. When I get to row 3, I'm going to be dealing with this. This is row 3. So here we are down here at row 3. So I'm going to have 5 and negative 2. All right, and this is still row 3, so I'm still going to be doing 5 and negative 2. Okay, So now let's do the columns. You can do the columns sort of all at once. So in the first column, then I'm going to be multiplying by the first column. So the first column is 3, negative 1. So here we are in the first column. So this is going to be 3, negative 1. And 3, negative 1 again. Okay, if I'm in the first column, I'm going to use the first column. Now here I am in the second column, so now I'm going to use the second column. All right, so all you have to really worry about is that the rows will come from the first matrix and the columns will come from the second matrix. Once you have that, then if you're in the second column, then you just record the second column. If you're in the first row, then you record the first row. So anyway, the second column is negative 2 and 5. So I could just write negative 2 and 5 all the way down. So it'll be a little quicker if you sort of duplicate all your rows and then all your columns ahead of time. And then you can just go back and concentrate on multiplying and finding the sum. Okay, so now I can work very, very quickly. So this is going to be negative 9 and negative 4. Put these together, and that's 13. Okay, this is going to make positive 6 and 20. Put them together, that's 26. This is going to make 15 and 2. Put them together, that's 17. This is going to make negative 10 and negative 10. Put them together, that's negative 20. All right, see how quick this is? And now we have our final answer. So I have 13 and 26 and 17 and negative 20. And that's it. That's how you multiply matrix A times matrix B. All right, let's do another practice problem, but I encourage you to pause the video and try doing this one by yourself. Our first step is to check and make sure that this product is actually defined. Let's write down the dimensions of each matrix. So the dimensions of the first matrix are 3 by 2 because we have 3 rows and 2 columns. The dimensions of the second matrix are 2 by 3 because we have 2 rows and 3 columns. Now, for this product to be defined, the inner dimensions must be the same. Okay, and they are, so this is okay. Now the product will have the outer dimensions, so the product will be a 3 by 3 matrix. Now, because the product is a 3 by 3 matrix, I'm going to set up an empty 3 by 3 matrix. And I'm going to guide myself with lines. And again, I'm going to make this very large for now because I want to show all my steps and leave myself plenty of space. So I'm going to use these grid lines to set up for a 3 by 3 matrix. Okay, so now I'm all set with 3 rows and 3 columns to work in. So to find the product, we are going to multiply rows by columns. All of the rows are going to come from the first matrix, and all of the columns are going to come from the second matrix. By the way, sometimes they refer to one element at a time. So if this were a test or a quiz, instead of having you find an entire matrix, I might give you a question where I said something like this. Find element T, let's say 2, 3. Find this one element of the product matrix. So this would mean that I want the element from the second row and the third column. So let's just do that just one time. So let's say if I was going to find the element from the second row and the third column. So that would be this right here. Okay, so I would have to multiply the second row times the third column. And that would give me the element in the product matrix that is in the second row and in the third column. So I would multiply 3 and 0 times -2 and -1. And that's going to give me -6 and 0. And if I add these, that's going to give me -6. All right? So if I only asked you for the element T23, then the answer for that would be -6. So I just wanted you to be familiar with that notation. But anyway, let's get back to finding the whole matrix. When you're finding the entire product, sometimes it's easier to do all of the rows at once and then all of the columns at once. So let's go ahead and deal with row 1. So this is row 1. So that's why when we do rows times columns, in this row, it's always going to be 1, -4. So I might as well just write down 1, -4 3 times. Okay? Because in row 1, I'm always going to be using row 1. So now let's move on to row 2. Okay? This is row 2. And this is row 2 of my product. So to find the elements in row 2, I'm always going to be multiplying by row 2. So I might as well write them all down at once. Row 2, row 2, row 2. All right? And if I want to find elements in row 3, I'm always going to be multiplying by row 3. So in the third row, I might as well write down 2, 2, 2, 2, 2, 2. Okay? And it's the same with the columns. If I want to find the entries of column 1, I'm going to be multiplying by column 1. So I might as well write it down 3 times. -1, 2. -1, 2. -1, 2. Just speeds up the process if you do it all the way down. And it helps you avoid mistakes that you run into if you do it one at a time. So if I want to find the entries of column 2, then I'm going to be multiplying by column 2. So I might as well write it down 3 times. 4, -3. 4, -3. 4, -3. And of course, one more time, if I want to find the entries of column 3, then I'm going to multiply every time by column 3. So I might as well write it down 3 times. -2, -1. -2, -1, and again, -2, negative 1. So now I can just go back and concentrate on multiplying and finding the sum. So if I multiply here, I'm going to get negative 1 and negative 8. The sum is negative 9. Didn't quite leave myself a ton of space here. That's negative 9. Okay, if I multiply here, I'm going to get 4 and 12. Take the sum of that, and I have 16. All right, if I multiply these, I'm going to get negative 2 and positive 4. Put them together, and I have 2. Multiply here, I've got negative 3 and 0. Put them together, that's negative 3. Multiplying these, I've got 12 and 0. Put them together, that's 12. Okay, multiplying these, I get negative 2 and 4. Put them together, I get 2. Multiply these, I get 8 and negative 6. Put them together, and I've got positive 2. Multiply these, I've got negative 4 and negative 2. Put them together, and I've got negative 6. Okay, so now I'm ready to write my final answer. So my final answer will be negative 9, negative 3, 2. I'm just recording all of these results. And then I've got 16 and 12 and 2. And finally I have 2 and negative 6 and negative 6. So this will be the product matrix that I was looking for. This is the final answer. All right, let's take a look at problem number 2. If I want to find the product of these two matrices, first I need to make sure that it is possible. So the dimensions of the first matrix are 2 by 3. This matrix has 2 rows and 3 columns. The dimensions of the second matrix are 2 by 2. Now, for matrix multiplication to be possible, the inner dimensions must be the same. So these are not the same. So that means that this matrix multiplication is not possible, or we could say undefined. Okay, so sometimes I say not possible, sometimes I say undefined. Let's take a look at number 3. Let's see if this product will be possible. The dimensions of the first matrix are 4 by 4. This is a square matrix. It has 4 rows and 4 columns. The dimensions of the second matrix are 4 by 1. It has 4 rows and 1 column. This is a column matrix. For this multiplication to be possible, the inner dimensions must be the same. And they are. So that means this matrix multiplication is possible. Now let's talk about the dimensions of the final answer. The dimensions of the product will come from the outer dimensions, which in this case are 4 by 1. So these are the dimensions of the product. Now that we know the dimensions of the product, let's set up an empty matrix that has dimensions 4 by 1. So I'm going to set up an empty matrix that has 4 rows and 1 column. So I need 4 rows. And I'm just only going to have 1 column. So this will be the setup for my empty matrix. Now, remember the rows come from the first matrix, whereas the column will come from the second matrix. Okay, so my first element, this is row 1, column 1. So I'm going to be multiplying row 1 times column 1. Okay, and I suddenly realized I'm going to need more space than this. So I went ahead and created a very big matrix, and you'll see why I needed to make it so tall. But notice I have 4 rows and 1 column in my empty matrix. Okay, so first let's go ahead and calculate, or at least set up for this element, which is in row 1, column 1. So that means I need to multiply row 1 times column 1. So row 1 is 2, -3, 4, and 1. This is row 1. And I need to multiply that by column 1. Column 1 is -2, 3, -1, and 1. So I have row 1 times column 1. Let's set everything up, and then I'll do the calculations later. So my next element is row 2, column 1. So row 2 is -1, -1, 3, 2. So that's -1, -1, 3, 2. So this is row 2. Column 1 has not changed. So we're just going to wind up using the same column 1 over and over again. All right, the next element is row 3 and column 1. So now I'm going to be doing row 3. Okay, row 3 times column 1. So 2, 0, 0, 5 is row 3. So I'll have 2, 0, 0, 5. That is row 3. And then still we have the same column 1, -2, 3, -1, and 1. And one more time. This element is in row 4, column 1. So I'm going to multiply row 4 times column 1. All right, row 4, and again, column 1. So 1, 4, 0, -3. And column 1 is still -2, 3, -1, 1. So you see why I had to make this so tall, because each entry, each element has a matrix that is 4 tall. So now I'm just going to go ahead and do the calculations. So I'm going to multiply each of these together. So this is going to give me -4, -9, -4, and 1. And then I just need to find the sum of all of these. So that's -16. Now, for this element, I have +2, -3. I'm just multiplying -3 and 2. Add them all up, and you get -2. Okay, for the next element, multiplying again straight across, I'm going to have -4, 0, 0, and 5. Add them all up, and you get 1. And for the last element, multiplying straight across, I'm going to have -2, 12, 0, -3. Add them all up, and you get 7. So these will be the elements of my final answer: -16, -2, 1, and 7. So this is the final answer for number 3 right here. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.